live. I'm just going to wait a bit. We got like 4 people looking at the moment. I'm still looking at about 4 people. But I'm still going to go ahead and I think start in about 2 minutes or so. All right. Well, I think that's enough waiting. All right, guys, let's go ahead and do this here. We're starting a new topic. This is the rational root theorem. I alluded to it a couple of times during our last couple of sessions here. This is very closely tied around with the fundamental theorem of algebra that we were doing before. So let's go ahead. Today is 3/19, and this is for all class periods. So here we go. The first bit, it's kind of an old hat for us here. Determine which of the following numbers, -5, -1, +1, and +5, are roots of f of x, given that this is our f of x. So we got 1, -5, -1, and +5. As always, I recommend that you start with either 1 or -1, alrighty? Let's see here. So we'll go ahead and, I don't know, I'll try 1. I don't know if that's going to work or not. 1 times 1, add, multiply, add, multiply. All right, so that one worked out just fine. So since we got a 0, we can go ahead and use the depressed polynomial that we created to look for another one. Let's go ahead and use -1 just to see if that works out. We've got -1 times 1, add them together. That gives us a +5. Ah, fantastic. Okay, now if you wanted to stop here, keep in mind that this is x minus 5. So we can already tell, just looking at it, that the last root's going to be 5. But if you're a big fan of synthetic division, go ahead and do it. You do end up with that same result. So the roots for this one are going to be -1, +1, and +5. And according to the fundamental theorem of algebra, we know that there are 3 roots. So we found all 3 of them. Alrighty? Cool. Same thing here. This time we've got some fractions built in there. It's still not a big deal because if it works out right, you're going to be getting rid of the fractions anyway. Let's start with -1 anyway, though, because that's, again, what I always recommend to do. Start with positive and -1. -2, -1, +1, -1, +1, and 0. Oh, great. So we found one right off the bat. I'll be honest, I don't know what's going to work next. So let's go ahead and try, well, we'll try +1. 2 minus 1 is going to be 1, times 1 is 1. Oh, great. That one worked too. Now, if you are, again, aware that this is what you're looking at next, you can solve that, subtract 1 from both sides, divide by 2. If you, again, are a big fan of synthetic division, we can go ahead and do this. -1/2 is going to be the last one here because you're going to get a negative result there. So we'll bring down the 2. -1/2 times a +2. You can use your calculator for it if you need to, but you do get -1, remainder 0. So everything is grand. The roots are -1 and +1 and -1/2. Alrighty? Cool. So you've got experience determining if a given number is or is not root of a given function. But you might not have been aware where those number choices were coming from. Every single time I just give you a list of numbers, and here's where it is. The rational root theorem states that if P over Q is a rational number in lowest terms, and P over Q is a zero of the function, then Q is a factor of the leading coefficient, and P is a factor of the constant term. All right, a lot of words. We're going to break it down here. In other words, if P is a factor of the constant term, Q is a factor of the leading coefficient, then P over Q might be a zero of the given function. Here's what I mean. Okay, this is your P. This is what's going to go on top. This is your Q. This is going to be what goes on the bottom. Alrighty, and if you want to think of it kind of like, I don't know, kind of like a lovely scorpion. This is my bad attempt at drawing a scorpion, where what's on the end is going to go on top of, like it's getting ready to attack there, the other numbers. All right, the factors of P, which is this right here, 6 is 1, 2, 3, and 6. Those are all the numbers that are going to go into 6. Somebody just asked, I don't really know what to say if this is easier than the fundamental theorem. Honestly, they kind of all merge together into a bit of a gobbledygook. Here, you're going to come up with the list of numbers that you would use when doing the fundamental theorem. So they're all tightly related. And even those then still tie back into the remainder theorem, which is that whole, looking for a remainder of 0 bit. Anyway, back to this. 2, the only numbers that go into 2 are 1 and 2. Alrighty? So what we do is we list all of the possible combinations of P over 2. If I were to make a big, massive, weird fraction, and I can put those 4 numbers on top and those 2 numbers on the bottom, we're going to make a list of all the combinations. All right. Remember, we want positive and negative. 1 over 1, that's 1. 1 over 2, that's positive, negative 1/2. All right. And we've taken care of the 1, so we don't have to worry about doing anything with that one anymore. All right. And we'll keep going. 2 over 1. So we have positive, negative 2 over 1, or 2. Positive, negative 2 over 2, that's 1. We already did that one. So we kind of can just, ignore that. Next is going to be positive, negative 3 over 1. And then positive, negative 3 over 2. Okay. And we've done the 3 now. And then finally, we're going to do the 6. Okay. Positive, negative 6 over 1, which is positive, negative 6. And 6 over 2 is 3, so we've already done that one. Okay, so these are all of our potential roots. If you can find it by synthetic division, it's going to be one of those 1, 2, 3, 4, 5, 6, 12 numbers. Alrighty. Yes, sorry about the dog. That would be Tulip, probably. You can test if a number is a root of a function either by substitution, which we really haven't done much with in a while, or by synthetic division. All right. Test the potential root positive 3/2. That comes from this right here. Both positive and negative 3/2 are possible. If it's a root, then f of 3/2 should give us 0 by the remainder theorem. Synthetic division, here we go. 3 halves. And let's go back to the function. What was it? 2, negative 1, negative 6. 2, negative 1, negative 6. All right. Bring down the 2. Multiply. Guys, you can use your calculator to do that. 3 halves times 2. 2's cancel out. You end up with 3 here. Minus 1, that gives you 2. Again, you can use a calculator if you're not comfortable with fractions, but you do end up with 3 in this case. Okay, same result as what you got before. All right, so we end up with negative 3. This is totally not a 0. All right, so 3 halves is not a root. Okay, if you wanted to do it by substitution, you could. That would look like this: 2, nice happy set of parentheses, squared, minus 1x, empty parentheses there, minus 6, and then you would just do 3 halves in both of those places. You're probably not going to go with that. I just think this is simpler to just write it out and not have to worry about parentheses. Again, if you're doing that correctly, you can just go ahead and put it in your calculator, and it'll give you the right answer. Okay, let's go back to this. We've got 2, negative 1, and negative 6. This time we're testing negative 3 over 2. All right, bring down the 2. This time when you multiply, you end up with negative 3. So when you add them together, you've got negative 4. And now we've got positive 6. That worked. So yay us. We found one of them. Again, if you wanted to stop right now with synthetic division, this would be 2x minus 4. Set that equal to 0, and you'll find the other one. If you just are a big fan of synthetic division, go ahead and continue with it. Bring down the 2. 2 times 2 is 4. And we again have a remainder of 0. So the 2 roots that you're looking for are going to be 2 and negative 3 halves. And we got that from this list of 12 choices. You might be thinking, oh, wait a second, you told us which ones to do. Yeah, I did. This is, and if you remember, I mentioned this in class a bunch of times, there's going to be a lot of trial and error in this unit, okay? It's the way it is. You probably would have started with positive 1 and negative 1. Neither one of them would have worked. At that point, you know, maybe you went into the 1 halves or the 2s. It's entirely possible that you go through pretty much the entire list before you find one that works. Or you end up with getting the right one, you know, right off the bat. It's a little bit of luck and a little bit of experience. The more of these you do, the more likely you are to guess the right number to try first. But other than that, there's not really a fix-all for it. All right, let's do the same thing here. All right, once again, like that scorpion analogy I talked about here, if this is the head of our scorpion here, where the back end, the tail, comes on top of, all right, like it's ready to attack the one in front, the factors of 4 are 1, 2, and 4. The factors of 3 are 1 and 3. We just have to build all of them. 1 over 1, that's positive negative 1. 1 over 3, positive negative 1/3. 2 over 1, positive negative 2. 2 over 3, positive negative 2 over 3. 4 over 1, that's positive negative 4. And finally, positive negative 4 over 3, or 4/3. All right, so once again, we've got 12 options of what we need to look at. Yes, good morning. Welcome. Again, there's going to be two of them. We know that because the degree here is 2. That was from the fundamental theorem of algebra before. We don't know what they're going to be. I don't even know what they're going to be. It's been a while since I've looked at this particular set of notes. So let's just go ahead and do it. 3, -1, and 4. Okay. The fact that there's a 3 in front, I do know one of them is going to be a fraction. So it's going to be one of these 3 guys here. But we'll just go ahead and start with, let's see, that is not going to work. So no, that didn't pan out. Fortunately, we have a whole bunch of them here. We do -1. Okay, bring down 3. 3 times -1 is -3. Add those together, you've got -4. And there's our 4. Okay, so we have found that -1 is going to be one of our roots. Okay, the last one, I'm just going to go ahead and jump into it. It's going to be 4/3. Okay, how do I know that? Because this is 3x minus 4. And if you set it equal to 0, add 4 to both sides, divide both sides by 3, you end up with 4/3 or 4/3. Bring down the 3, multiply, that gives you 4, and 0. So that is our other rational root. So the answers here, the roots of g, are -1 and +4/3, 4/3. Alrighty? Hopefully there's no issue at the moment. If you've got a question, go ahead and type that in. You can use remind, or you could just go ahead and type it right into the chat here in YouTube, and I'll be able to see it that way. But since I'm not seeing anything at the moment, non-rational roots. Okay, synthetic division is only going to work if the roots are rational. The rational root theorem only works for, well, it's part of the name, rational roots. Okay? What that means is we are going to have to use, like we did yesterday, I think it was, either completing the square or quadratic formula. Okay? According to the rational root theorem, the potential roots are going to be all the factors of 2, okay, because that goes on top of this guy, over all the factors of 1. So the choices end up being positive -1 and positive -2. Okay, and you know what? If you want to try it, we can. Keep in mind, like when we were doing long division, we do need to include a placeholder. So this is going to be 1, 0, -2. If we tried 1, nope, that doesn't work. We can try -1. That doesn't work either. We can try +2 if we want to. That didn't work. And we can do -2. All right, bring down the 1, -2, -2, +4. Okay, so in all of those cases, none of them end up working. Where to get the -1 from? Well, keep in mind, you're always looking at both the positive and negative numbers. Okay, so when I say 1/1, that's 1, but we need to consider both the positive and negative version of that number. 2/1, that's 2. We need to consider both the positive and negative versions of that number. Okay? Now the actual roots for this, here they are right there, are negative square root of 2 and positive square root of 2. The rational root theorem does not list any possible non-rational roots. Okay? And like we've mentioned before, non-rational roots, that includes irrational, like positive and negative square root of 2, and it also includes imaginary, something with I involved, or square root of negative 1. Okay. We'll do this one right here. According to the rational root theorem, let's see, that's a 1. And you're just going to put it on top of that. You're looking at all the combinations of 1 over 1. Not a whole lot of combinations there. Remember, we want the positive and the negative, so it's going to be positive, negative, 1. We could try them both out. They're not going to work. Okay? So we would need to solve it another way. You can use completing the square. You can use the square root method in this one because there's no linear term, or you can again do quadratic formula. Now the actual roots are negative I and positive I. Again, same thing that we said before. The rational root theorem does not list any non-rational roots. So whether we're talking imaginary, like we have here in 21, or in the previous where we had positive, negative square root of 2, those are irrational. The rational root theorem just does not help. Okay, here we go. Let's go ahead and do this one. This is the graph of this. I know we are going to graphing eventually. That's something we're probably going to hit next week. But for the time being, I'm just going to kind of show them to you as, well, just as a reference when we're talking about the zeros. Okay. Once again, the tail goes on top of the head. So we have 1 and 2, the list of all the numbers that go into 2. And we have 1, 2, and 4, all the numbers that go into 4. All right. 1 over 1. That's already listed for us. 1 over 2, that's already listed for us. 1 over 4, that's already listed for us. 2 over 1 was not listed, so we have plus minus 2. 2 over 2 is 1, we already did that. And 2 over 4 is 1/2, so we already have that as well. That is a whole W. Oh, I see what you're saying, the graph. Yes, it does look an awful lot like a W. Polynomial functions are going to do that. When we get into that next week, you'll see what I'm talking about there. But I don't want to throw too much at you in one shot. You've got the homework that's already posted in Schoology for you to work on for this. We're probably going to work on this both today and tomorrow. We're not going to go through all of the notes on this today. And then somewhere in between there, we'll get a CFA or two in there as well. Alrighty. The synthetic division, try -1 as a root. Okay, let's go ahead and do that. 4, -8, -3, +7, -2. Now I know ahead of time it's going to work. Remember, these things are roots or zeros. Right there, that's a -1. That's where it's touching, is -1. So we can be pretty sure that's going to work out for us. Multiply, that's -4. Add them together, that's going to be -12. Multiply again, that's going to be +12. Add those together, and you're looking at 9. Someone asked me a question here. Nope. 1 times the -9, we've got -9. Add those together as -2, and we're left with +2. So yeah, we've got a remainder of 0. That one worked out just fine. Okay? What might be the other rational roots of f of x? Now, like I said, roots are zeros. If they're real, they are the places where it's going to touch or cross or whatever the x-axis. So the other numbers, this is 2, and this, since we're counting by halves, that is going to be a positive 1/2. So let's go ahead and do that. We'll use the depressed polynomial. Okay. To find it. Let's go ahead and do 1/2 now. Why not? Bring down the 4, multiply that, and we now have 2. Add them together, it's -10. Multiply, we're looking at -5. Add together is 4. Multiply together, and you get 2, and that cancels out. Marvelous. Okay. And what was the other one we said was going to end up working? We said 2 was going to work for us. All right. 2 times 4 is 8. Add those together, you've got -2. Multiply those, you've got -4, and it goes away. All right. Well, let's see. Fundamental theorem of algebra tells us that there should be 4 roots for this. We found 3 of them. -1, 1/2, and 2. Keep in mind, this statement here is 4x minus 2. You can set it equal to 0 if you want to, and you'll get to the answer that way. Or if we keep going with synthetic division, let's do 1/2 again. Bring it down, multiply, add. There we go. So if you remember the term we talked about previously, multiplicity, let me write that down for you. Multiplicity. Okay. Multiplicity says that we can have the same root show up more than once. Okay. So what you've got here now is, what was the first one we said? -1. We have 1/2, and 1/2 happened twice. And then you've got the number 2. Alrighty. So while this one has 4 roots, it has 3 distinct roots. Okay. Distinct meaning the same thing as different. Okay. There's only 3 different numbers listed, even though there are 4 of them, because the 1/2 is counting as 2 of the roots. So there's 3 distinct roots. All right. How long have we been going here? About 34 minutes. Do I want to keep going here? Oh, look at that. Well, might as well finish it up because I think that's the end. Here we go. This is a real-world problem here, okay? This models the motion of a roller coaster. The x-axis, this is your time. Okay? And the y-axis is going to be the height. Okay? And this is where time equals 0. That's the start of the ride. Okay? Meaning the ride has been going for 0 seconds. Or minutes or whatever. I don't remember what it says. Okay, so when is the roller coaster on ground level? Well, we know it's going to be on ground level here. And it's going to be on ground level here. And because we're dealing with an equation, it's also on ground level here, but this has no meaning for us because that's before the ride even started. To answer the question, when it's ground level, you need to find the X intercepts, which means you need to find the zeros or roots. All right, here we go. First off, 0 is going to work. Okay, we did this in class at one point, if you were there. We do need a placeholder for every term that's missing, including the last one. And if you put a 0 in, what I told you want to do is go ahead and use 0 right away. Okay, so there's our first depressed polynomial. Doesn't look very different from the other one. All right, well, we're using this to find the other zeros. Look at the graph. This number right here, that's 3. Okay, so we can tell just by looking at the graph that 3 is going to be another one that works. Bring down the 3. That's a 9. Plus 13, that'll be -4. Multiply, you've got -12. Add together is negative. Why is that there? -15. Multiply, it's -45. And you end up with 0. Okay? 3, -4, -15. It does ask us to find all of the roots, so we can go ahead and do that here. We have 2 left to find. All right, this down here does not look like a very happy number. It seems to be between -1.5 and -1.75. Well, knowing that the possible rational roots, let's see, 45, that's 1, 3, 5, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 should work, 10, 11, 12, 13, 14, 15 works, and then finally 45. So you would have to try all those numbers on top of 1 and 3. Okay, keep in mind we have plus minus for every single one of these. Since I could see from the graph that this is somewhere in this neighborhood, okay, this is your 2, -2, and this is your -1. It's a little over halfway between 1 and 2. So you're looking for a little over halfway between 1 and 2. I'm thinking, and again, I don't really know, let's try -5/3. Random go at that. Okay, the 3's cancel out. You end up with -5. Add those together, you've got -9. And hey, look at that. We've got 15. And then finally, multiplicity again. This is 3x minus 9. That means 3 is going to work again. And there we go. The roller coaster is on ground level 3 seconds after the ride starts. And I believe that's the end of that one. So guys, that is using the rational root theorem. Hopefully that was helpful for you. Be sure to reach out to me if you've got any questions. You can go via Remind or whatever. I am going to be reaching out to you soon with some IXL assignments that various of you need to do based on the last test. I wasn't able to, if you weren't here Friday, you don't know what those are yet, and since we're going to be out for a bit, might as well give you time to work on that as well. All right, guys, I will talk to you all later.